Alright guys, so we're jumping into Unit 2, starting off with polynomials. The word polynomials has the prefix poly, which means many, and the root word nomial, which kind of makes us think of numbers. So a polynomial is going to be many numbers or many numbers and variables. So we would call this many terms. So a polynomial is something that has many terms. You can see examples of polynomials in this column over here. And as you see, or as you may remember, a term, we'll fill in this definition right now, a term is any time you have numbers, variables, or numbers and variables multiplied together, separated by addition or subtraction. So you see that down here. This one's a really great example of that because it has three terms, so many terms separated by addition or subtraction. So that's what a polynomial is. When we talk about polynomials, we often refer to the polynomial's degree. The degree is the largest number found in the exponent. So if you look at all the exponents in a polynomial, what's the largest number found there? That'll often be the degree. Standard form is achieved by arranging the order of the terms in a polynomial from greatest to least exponent. So if someone asks you to put a polynomial into standard form, we're asking you to arrange the terms so that they go from greatest to least. And then the last important word that we use is leading coefficient. You should remember that coefficient is the number in front of a variable. So like if you had 3x, 3 is the coefficient. It's the number in front of the variable. So the leading coefficient is the coefficient of the first term when a polynomial is written in standard form. So let's go ahead and look at the first table there. When we classify polynomials, basically when we name polynomials, we're going to give them a first and a last name. Their first name is their degree. And so remember that a degree is the largest number found in the exponent. So we start off with the hardest one to see. 10 is actually degree 0 because there's an invisible x to the 0 right here. You should remember last year that anything raised to the 0 power is 1. So if I have x to the 0, I really just have the number 1. So 10 is secretly multiplied by an x to the 0, which means that the largest exponent in that polynomial is 0. When the degree is 0, we name it a constant polynomial. The second example, 5x plus 2, again written in standard form because it's going from degree 1, there's an invisible 1 on that x, to degree 0, remember the invisible x to the 0 is there, so it's going in order from greatest to least. And when something has a degree of 1, meaning its highest degree is 1, we call it a linear polynomial. Next example, again in standard form because it goes from second degree to first degree. Standard form always goes from greatest to least. And the highest exponent is 2, so it's a degree 2, which we call a quadratic polynomial. I know that's like kind of counterintuitive because we often think of the word quad as meaning 4, but in this case it means 2. Alright, the next example, again going in standard form, it's going degree 3, degree 1, degree 0. So it's in standard form going from greatest to least. And the highest exponent is 3. When the highest exponent is 3, we call it cubic. That's one that kind of makes a little bit more sense, like a cube. Alright, if the highest exponent in the polynomial is 4, we call it a quartic polynomial. If the highest degree is 5, we stop calling it by a special name. As the degrees get higher, we don't have any special names, so we would just say that this is a fifth degree polynomial. And then the next one we would say is a 6th degree polynomial. And then the last one is an nth degree, meaning that it could be any number possible. And we would literally just call it an nth degree. So again, as the numbers get larger, above 4, we just refer to it as 5th degree, 6th degree, 7th degree, and so on. So again, we're naming polynomials. So their first name is their degree. Their second name is based off of how many terms that there are. So in this example, there's only one term. There's only one thing there. If there's one term, we call it a monomial. Mono meaning one. So it has one term. The next one has two terms. 3x squared is one term. 10x is the second term. And so we call that a binomial. Bi meaning two. The next one is a 3-term polynomial, so we call that a trinomial. And then this last one is a 4th degree, not a 4th degree, a 4-term polynomial. Just like with the degrees, we run out of names after the third, after 3 terms. So we would just call this a 4-term polynomial. So look at the first example there. As you can see, it's not written in standard form to start because the first term is degree 0. Anytime it doesn't have a variable, it's degree 0. The second term is degree 1, and the third term is degree 2. So to put it in standard form, we have to go from greatest to least. So we put the second degree first, first degree, 0 degree. So now it's in standard form. Keeping in mind that -9 would be considered the leading coefficient because it's the coefficient of the first term when it's written in standard form. And so we can tell it's second degree because that's the highest exponent in the polynomial, and there's 3 terms. So the first name of the polynomial is quadratic. That comes from the degree. And then the last name of the polynomial is trinomial. That comes from having 3 terms. So let's put number 2 in order in standard form. So first term, degree 0. Second term, degree 3. So I need the degree 3 to come first. So negative 6x cubed. This minus sign is attached to the 6x cubed, so it has to move with it. And then plus 5. That's now in standard form with a leading coefficient of negative 6. And it's degree 3. And it has 2 terms. So based off of its first name, which is the degree, we're going to call it a cubic. And based off of its last name, number of terms, it's got 2, so it's a cubic binomial. First name, last name. All right, and then the last thing we're going to quickly cover is how to add and subtract polynomials. It's essentially just combining like terms like we saw last year in 7th grade. So if we want to add polynomials, we're basically just going to be combining any like terms we see. So in this first example, not sure why it's labeled number 2, we're looking to combine positive 5x squared and positive 3x squared. To be a like term, you have to have the same variable and the same exponent. So in total, I have 8x squared. And then I'm going to look at my x terms. I have 8x and negative 1x. So in total, I have 7x. And then lastly, I look at my constants, and I have negative 10 and negative 12, which give me a total of negative 22. And the answer did ask me to write it in standard form, so that's why I went from degree 2 down to degree 0, so that it goes 2, 1, 0, because standard form is from greatest degree to least degree. Okay, so for the next one, I'm just knowing that I have to write it in standard form. I'm going to start with the cubic term, the highest degree. So I have negative 1x cubed and positive 7x cubed. So in total, I have 6x cubed. And then I'm going to look at my x squareds. I have negative 9x squared and positive 9x squared. So I actually have no x squareds when I add these together. Then I'm going to look at my x's. I have positive 8x and negative 8x. So again, my x terms cancel out. And I'm finally left with positive 4 and negative 10, which combine to give me a negative 6. So my answer is in standard form, going from degree 3 to degree 0. When we subtract, we're going to add the opposite, just like you guys did when we were doing integers. We're going to change it to addition and add the opposite. So instead of 9x squared minus 4x plus 8 minus 12x squared minus 6x plus 3 minus 3, I'm going to change it to addition, and I'm going to make every single thing in the parentheses opposite of what it is. So this is going to become negative 12x squared, positive 6x, and positive 3. Because that's all subtraction is adding the opposite. So now I combine my like terms. Positive 9x squared, negative 12x squared is negative 3x squared. Negative 4x and positive 6x is positive 2x. And positive 8 and positive 3 make positive 11. And so for the next one, I'm just going to add the opposite. So the first polynomial is unaffected. That stays exactly the same. But then I change it to addition and make every single thing opposite. So negative 8, negative 5x, positive 3x cubed. And then I'm going to combine my like terms. So I have negative 2x cubed and positive 3x cubed. That combines to give me 1x cubed. I have negative 7x squared. That's my only x squared term, so that's just negative 7x squared. I have 1x and negative 5x, so that makes negative 4x. And lastly, I have 8 and negative 8, so those two cancel out. So my final answer is x cubed minus 7x squared minus 4x. Please complete the adding and subtracting problems at the bottom of this page. Pause the video, and then when you're finished with them, unpause it for the answers. Alright, so here are the answers to the problems on the bottom of the page. They are all written in standard form, going from greatest degree to least degree. That's a good habit just to get into with all of your polynomials, even if the directions don't say to do so.